Hello everyone, this is Mayur Chavan and today we are going to discuss something about computer network. So very first, computer network is your third year computer engineering first semester subject. So let me just tell you why this subject is kept in third year computer engineering. Because in second year computer engineering you have studied about basics or core subject of computer engineering. So nowadays you are very well aware about why network is required, because all of you required a mobile network, like you can carry your laptops, like you are using your cell phones, and you don't want to install any software on your cell phone or on your computer. You just want each and every software on cloud, so you can remotely access it from anywhere at any time. And only because the need of today's projects is all about distributed systems, and for that distributed system and for that cloud access we require network. It's called as computer network. And while developing these projects you require knowledge about computer network, means how we are establishing these kind of networks, and how we can configure these networks, how we can resolve the issues we are getting while installing, configuring and using that network. And only because this computer network subject actually kept in your third year computer engineering first semester. So now subject code for this subject is 310245, and examination scheme is having 30 number in semester theory examination and 70 number end semester theory examination. In previous academic year, second year, you have 50 marks of online examination and 50 marks theory examination. But in this semester or in this academic year, you do have 30 number of in semester theory and 70 number of end semester theory examination. Now, these are the vision and mission statements of our department. We are trying to use more and more free and open source softwares for our today's need. And why we are studying this subject, as I told you earlier, so these are the course objective, and we are trying to fulfill this objective with the help of theory and practicals for this subject. So what are the course outcomes of this subject, means what we are going to study, and what we can achieve after studying this subject, and how this subject is going to help us for this semester mini project implementation, next semester seminar implementation, and for your final year project implementation, and how we can guide outside world, our relatives, our friends, to purchase a new mobile or to purchase a laptop. What is the configuration required to meet today's network requirement? So these are the outcomes of this subject, and with the help of these objectives, outcomes, we can very well understand this subject, and we can actually implement it or use it for our future. Now the syllabus. So some of you are aware about 7-layer architecture of computer network communication. This architecture, or you may call it as a ISO OSI reference model. ISO stands for International Organization of Standardization. OSI stands for Open System for Interconnection. So these units are like your 7 layers. So very first unit is your physical layer, second unit is logical link control layer, third unit medium access control layer. So while studying that ISO OSI reference model, their first layer is physical, second is data link, third one is network layer, fourth one is transport layer, fifth one is session, sixth one is presentation, and seventh one is application layer. So in this syllabus, they have combined application, presentation, and session layer in application layer, and they have divided data link layer in two different layers, like your second unit or third unit, logical link control layer and medium access control layer. So these are the 6 units we are going to study in this computer network subject. So what are the books we have to use for this subject? So very first book you have to use is Data Communication and Networking by Behrouz Forozan, Tata McGraw Hill publication. Second book you have to use is Computer Network, a top-down approach by Kuros and Ross, Pearson publication. Third book, Computer Network by Andreas Tannenbaum, PHI publication. Fourth book, Computer Network by Peterson and Morgan Kaufman, publisher. So these are the 4 books that you have to use, and I am also using that Data Communication and Networking by Behrouz Forozan book, McGraw Hill book, that is. We are using this book for our study and for our reference purposes. Right. So what is the outline for this subject? Means very first what we are going to study in this subject. What is there in that first unit? Physical layer, and why it is called as physical layer. So before we can actually jump on our very first unit, we have to study few, or we have to understand few data communication concept. Means how the data is communicated from one system to another system, or how it will be communicated using one application to another application in same system, or how it will be communicated within two different platforms like open source operating system, or let's say commercial operating systems like Windows Linux, like Windows Android, these many operating systems. So we have to understand data communication first, and what are the things required for that data communication, how the data is communicated. So this is just an outline for this subject. This is just an introductory part and what we call prerequisite for this subject. And that prerequisite, we are going to study about data communication system, what is computer network, applications of computer networks, network type, means actually how we are going to deploy our network, and that network is accessible up to what level or up to what range. It comes under your network type, and the types are local area network, wide area network, and metropolitan area network. There are many more types, like again personal area network, ad hoc network, client server network, peer to peer network. These many things we are going to study later. But now network types are local area network, wide area network, and metropolitan area network. Then after that we have to decide one specific sequence to deploy these networks, like we are placing elements or what you call entities in your house or in your room. So in that fashion we have to deploy our network, and only because our labs are looking like, and we'll experience our network. So these things comes under our topology. And then LAN standards. LAN standards includes sometimes hardware and sometimes many more things. Again, wireless networks. So these are the things we have to study before we can actually study our first unit, physical layer. So here if we see, so what are the components required for data communication system? So when we are communicating one information from one place to another place, so what are the things involved in that communication? What are the things actually communicated in it? So for that communication, very first what we required is sender. Another thing what we required is receiver. How we can communicate using wired network or using wireless network. So for that communication what we required is medium, and what type of information we have to send and receive, what type of data it carries is called as actual message. And the fifth and most important thing in data communication is protocol. So what is protocol? It is mentioned in that diagram that rule 1, rule 2 to rule n, and that is communicated from sender to receiver, rule 1, rule 2 and rule n. So protocol means without a protocol your systems may be in connected mode but they cannot communicate. If they wanted to communicate, so they require protocol. So what is protocol? Protocol is nothing but a set of rules that governs data communication. Protocol is nothing but a set of rules that governs data communication is called as protocol. Means without a protocol your systems may be in connected mode but they cannot communicate. If they wanted to communicate, so they require one specific protocol, and protocol is important thing in your computer network or in your data communication systems. And there are more than 51 protocols in computer network, and they do have their own specification, structure, functioning, use, advantages and disadvantages. So with the help of this diagram you can easily understand for any communication what we require is sender and receiver, medium, messages, and most important thing, protocol. Now let us just take few examples how that communication happens nowadays. So here are few data flow, you can call it as a modes of communication. Like first simplex, second one is half duplex, and third one is full duplex. So what is simplex communication? You can call it as a single way communication or one way communication. Examples: CPU to printer. While printing a data, we are providing command from CPU to printer, right? So these kind of communications are comes under simplex communication or simplex mode communication. Direction of data is available in the diagram. One way communication. Second one is half duplex communication. So in that half duplex communication, sender and receiver from these two systems, only one can communicate at a time. Both of them are not able to communicate at the same time. This kind of communication or mode is called as half duplex mode or communication. So example of this communication is walkie talkie. Maybe you have seen in movies or somewhere in serials or maybe somewhere with some applications, that walkie-talkie is an example of half duplex communication. And because they are saying in walkie-talkie that I am doing this over, over means their communication, first end communication is over. So after first sender is saying over, receiver is start communicating with that sender. So these kind of communications are called as half duplex. And third one is full duplex mode of communication. So in that full duplex mode, both sender and receiver or multiple stations are communicate at the same time or at a same point of time. And the example is like mobile phones, cell phones, these kind of devices. These kind of devices are comes under full duplex mode of communication. So these are just the modes of communication: simplex, half duplex, full duplex. And then types of connections: point to point and multi point. So in point to point connection, stations are directly connected to each other, means they need not to go to base station and then another point. Yes, they have sometimes they have to go to base stations and communicate with other point when they do have a base station for multiple point communication. But in point to point communication, they are not, or mostly they are not going to store data at centralized point. Most of the time they are able to store their own data, called as point to point communications. Means they are directly connected or they can directly communicate with the other point or other stations. This comes under point to point. Next one is multi point. Like you have seen in bus topology, using one single bus, two three computers or two three stations are connected. So using one single link, two three points or two three stations are connected using that link. This comes under multi point communication. Then next is computer network. What is computer network? A computer network is a collection of nodes connected using communication links and capable of sharing resources. In short, computer network is just a connected devices network. Maybe that devices are computers, means desktop, laptops. Maybe that devices are mobile phones. Maybe some other devices, communication devices, like the thumb impression machine, like many more machines we are using. So these connected devices are comes under computer network. And why these devices are connected? Just for sharing information from one place to other place, just for exchanging, interchanging information or data from one place to other place. And it is very useful for sharing of that data. It reduces our time and our resources, and because the network is required. And characteristics of computer networks are physical structure, which include topology, type of connection. Second characteristics, performance, throughput or delay. Third one is security. Fourth one is reliability. Physical structure means you are aware how we are placing that computers. It comes under topology, how they are communicating, how they are sharing their information using that topology. Types of connections we are using, like we are using USB 3.0, USB 2.0, like cables we are using, like we are using two Wi-Fi devices, like we are sharing data using Bluetooth, Wi-Fi. So types of connections. Performance means it, like bandwidth of one particular cable. Throughput, delay means in 1 second or in 1 minute how much data it is going to send, or what is the capacity of that cable, means how much data it is going to carry, 100 MB, 1000 MB, 2 GB, what is the capacity of that cable, it comes under performance of that device. Third one is security, means how secure your data is while communicating information from one end to another end, how secure is it, how your network is securing it. And fourth one is reliability, how we are going to check reliability of, let's say, network or any device. Reliability means at what point or time it is going to fail, and how much time we require to recover that failed frequency, which comes under reliability. And using this we can justify our network is reliable or not, means when it gets collapsed and how much time it will take to recover that things comes under reliability. So there are few questions comes into your mind. Ki what is internet then, and why computer network, and why internet, and how these things are separated. And some of you are thinking that these two things are same or not. So yes, we are going to discuss here what is internet. Internet. So internet is what? Internet is just network of networks. What is internet? Internet is just network of networks. What we are what we are trying to justify is computer network and internet. So we are saying that internet is a network of networks. So some of you are thinking that how is internet and who is providing us internet, how it is stored. So internet is just like your computer network, as we are saying network of networks. So we need not to store internet, nobody can store it, there is no tank of internet. Like sometimes we are going to store electricity or water or something, there's no need to store internet, right? It's just a network of networks. Like you are connecting two three computers, like you are connecting 4 5 mobile phones, 5 10 computers with each other using one switch or router. It's also a internet. And because we are saying that internet is a network of networks, so who invent this internet, how it is accessible to others? So in 1969, US defense US Defense Academy. So US Defense Academy, who has invented concept of connected computers. First of all, they were working with single standalone computers. Now they were start looking if they are going to connect these computers, so how they work. So they start searching about it, and they found concept of connected computers, and they call that connected computers as a computer network and internet. So in 1969 or 71 they have formed one ARPANET agency first, who controls or who have invented that internet. Who invented it? US Defense Academy in maybe 1969 71. They were start searching, they were start looking for it, and they formed one agency called ARPANET, Advanced Research Project Agency Network. The name of ARPANET is Advanced Research Project Agency Network. And below ARPANET there is INA agency, and the name is Internet Assigned Number Authority. And after that comes ISP, Internet Service Providers, and then users, right? Right. So computer network and internet, these two are related, or sometimes you may call it as a same thing. Computer network is nothing but a connected devices, and that devices are responsible for data sharing or communication. Or internet is a network of networks, and computer network and internet invented, or means they have been found at the same time. So who invented it? US Defense Academy in 1969 or maybe in 71. So first they have formed that agency, Advanced Research Project Agency Network, then Internet Assigned Number Authority, then Internet Service Providers and users. So when we are saying that internet itself is a network, and they are just providing access from one system to another, or from one device to another, so there is a control of this or these kind of communications. So how these devices or how this control is, so users are communicated or communicating using ISP, Internet Service Provider. ISPs are controlled by INA, Internet Assigned Number Authority, and INA controlled by ARPANET, Advanced Research Project Agency Network. So the flow of internet control is like this. Means end users are controlled by internet service providers. Internet service providers are controlled by Internet Assigned Number Authority, INA, and INA authorities are controlled by ARPANET, Advanced Research Project Agency Network. So this link is like that. So we have clear here, internet is a network of networks, and we need not to store internet. There is no tank of internet, and using that tank, that internet service providers are providing us internet. Yes, we do have plan of 1.5 GB per day, 2.0, let's say 2.5 GB per day, but these things are also controlled by, or control using few algorithms by that internet service providers. So overall internet is controlled using ARPANET, after that INA, after that ISPs, and then end users. So the sequence is like this, and here we justify clearly the difference between, or the similarity between computer network and internet, and these are the characteristics of that network's physical structure, performance, security and reliability.